I'm KJ5HAU. I'm the tech coordinator, tech talk coordinator for the club. This month we have our tech talk on AREDN, the Amateur Radio Emergency Data Network. This is put together by Steve Arns, KM5HT, and John Skier, K5SKR. So without further ado, I will hand it over to you guys.
Thank you, Michael. Well, as Mike said, AREDN is the Amateur Radio Emergency Data Network. It is actually a digital node for ham radio, operating 100,000 times faster than packet, 40,000 times faster than VARC. So 100 megabits. Essentially, this is internet on ham radio frequencies. And so pretty much what we use is commercial off-the-air hardware. This is our original 2 gigahertz node. And its predecessor. This was the very original piece that we made, AREDN. It's probably 20 years old. We can no longer run. AREDN actually doesn't run on this. Its predecessor does, and we have actually, I've seen them used around. So even these old antique Linksys are available, and this is all based on OpenWrite, the open Wi-Fi.
Yes.
And we've modified it to work with our stuff.
We get the lights there so we can see the screen.
I'm getting you good side, John.
Oh, well, I need to turn around, face the screen. All right, so we're running a commercial hardware. Interesting. We do have some hams that are actually operating this hardware into the kilowatt range. As hams, we can operate up to our full 1.5 kilowatts of power, but typically we're operating these things at 600 milliwatts, which is your standard Wi-Fi node power. The win is when we put that power into a dish, and this is about a third the size of dishes we got on the roof, we multiply that power by about 30. Now, obviously, when we multiply it by 30, we're getting a narrower beam. When we use these guys, we get 600 milliwatts, and this is actually an 18 dB 5 gig antenna. It's actually the one that I had at my house for a long time, and this is what we had up at Sherrill for a while. We've replaced Sherrill with a couple of these nodes, and the difference between these is about 20 dB gain. This is about 35 dB gain. So more signal, less problem with interference, better things work for us. How far can AREDN go? There is a node over in Europe that is going from the mainland to an island that's going about 200 miles. For us, we go about 4 miles. And of course, this is gigahertz. It works really well as long as you can see the target. And Steve's going to run us through some stuff. A lot of the stuff that we have to go through to make sure these links work and some of the challenges we've had on our links, we'll talk about it toward the end of this. And again, Amateur Radio Emergency Data Network. We use AREDN to basically provide internet when everything else fails. So where can we operate? AREDN's got 4 channels in the 900 megahertz band. That's the most friendly when it comes to obstructions. Right now, we don't have anything set up there. 2 gigahertz, we typically run it down there in those unshared -1, -2 channels. But we are also able to use all of the commercial channels that you and I use at home all the time on our 2 gig routers. The 3.4 gigahertz band was a place that we were looking at going because we share that only with the military. Unfortunately, the FCC took away about 10 channels from us in that band, and they have said that at any time we're subject to lose that band. So we're not seeing a lot of ham investment in 3 gigahertz, but this is one that's really still worthwhile because there's nothing in there. It's us and the military, and it makes it easy.
How many products are available for use or purchase in the 3.4 gig band? Just like
There are 3 or 4 vendors, and you have to provide your ham call sign to get the equipment from those vendors because they will not. It is not just unlike the 2 gig and 5 gig. It's not commercially available. And then the place that we do all of our playing, the bulk of our playing, is down here in the 5 gigahertz range. We don't have a lot of interference in the 5 gig range. We do share it with a lot of different services. We're currently operating, here's a pointer here, we're currently operating on 160 and like 165 on the links that we're going to talk about here today. So we got a lot of places to play. We share it for the most part with other services. And again, it is line of sight, but when you use the high gain antennas, you can get really strong signals. It is not unusual in California. I'll talk about that in another slide. It's not unusual to get 25 to 30 miles.
Paul, got a question.
Paul,
What is the result of sharing the link with everybody else? Do they come on the channel when we are? Do we block each other out?
yeah,
Or what happens there in terms of this sharing?
because of our focus beam, we really don't, that's why we have the high, we shoot for a high gain signal
Yeah,
so that we don't wind up with interference. Being line of sight and point to point, it minimizes the interference. But yeah, what we'll see is what we've been seeing is some error rates. And so you see retransmissions of the packets.
so those would probably be caused by somebody else on the
But
band.
interference, yeah,
Right.
interference.
But not on the network, just on that same channel.
It's on the
In
same
our home,
frequency.
Okay, that's
Home Wi-Fi or whatnot.
Yeah. Yeah, the plus side of being line of sight is that, interference, it's almost sort of like being on a fiber. Your interference is minimized, but of course, the downside is if you can't see it, you can't talk to it. Come on, channel. There we go. All right, so what's AREDN used for? Predominantly, anything you can do on the internet, we can do with AREDN. Everybody in here could come pull out your phones. You could connect to the W5 HRC 5 gig or 2 gig, and you would be connected to our AREDN network, and you'd be using it to get your internet access. Slight violation of rules there because you're probably running an encrypted browser, and ham cannot run encrypted. So one of the characteristics of AREDN is all of our signals are not encrypted. All right, so typical shelter management, Red Cross backup, CERT opportunity. All of that is basically in the shelter realm and in the public disaster realm. We also have the ability, and a lot of this goes on with streaming video. We use a lot of video in AREDN to look for weather and traffic. We've got backpack portable AREDN nodes that they take out to parades, and it provides eyes on the ground for the parade director. So they can actually sit in the command post and look at what the crowds are doing. So you get the value of, one picture's worth 1,000 words. Well, they got full-time video. They can see what's actually happening. We use the camera to do weather monitoring. We also have the ability to run WinLink. Michael, you were working on that. Did you get it up?
Almost.
All right, so we're working on getting WinLink up. We can do mail, we can do chat. Obviously, you got the ability, voice over IP. We can run phones on the AREDN system. So as we're putting out deployments, as you're going into a shelter kind of activity, you can take a laptop with a micro router, and there's folks that have about 150, 200 of these that they just deploy as part of the shelter. Laptop comes in, they plug this in, and it makes it part of the AREDN network. And the entire shelter staff is able to operate on the AREDN network with our command and control stuff, the shelter work software, from a stick on their laptop. And these are just phenomenal. This is Steve's. I've got one. Travis has got one. Michael's got this little guy. I think this is probably the nicest piece of equipment we could get. It is a 5-port router. It has Wi-Fi and runs the AREDN software. This is 2.5, right?
Yeah, it's
So-
2.5.
I can run 2.5 gig Wi-Fi signal that my laptop can connect to from the living room.
It also does 5 gigahertz.
And it'll do 5 gigahertz that I can run AREDN on and have that signal connect out to the network right here on the ceiling. So this one node gives us, basically everything you need. It's, a router, it's 2 gig Wi-Fi, 5 gig connect to the internet.
Well, typically, what is the saturation level? How many laptops, phones, devices could be on this network before it came down to a crawl. In a typical scenario, how many would you think?
Yeah, okay, so as long as you're not running video, and you know, you're probably able to run 20, 30 without any issue at all.
20, 30, that sounds good.
But, and the nice thing about it, because these two are separate nodes and they network with each other, the nodes network to each other in a mesh. The signal will pick its own path. So in a sense, it's self-minimizing. Point to point.
How much is that all in one, you know, Father's Day's coming? The half AC, I think it cost me like 65.
Yeah.
No, it's
Yeah.
not bad, it's a pretty.
Yeah, this is really great. Like, yeah, as you said, 65, less than $80.
And the plug-in node that you got, the other one.
This was, you can't get these,
Oh,
but if you can find it on eBay, typically seen them for $50, $60.
No, the half AC has gone up a little, it actually is at $80.
It isn't?
Yeah.
So. And well, I didn't bring it in. This is the 5 gig node that we put on the side of Doug's house. And it passed the inspection of the wife. So. Compared to this guy, it's a big win. These are both 5 gig nodes. This is obviously the Omni, this is a directional. This provides us a really awesome signal. You can say small, light, this is all PoE, power over Ethernet cable. So everything that we put up there, we just put it out on an outdoor cable and it'll run for years. And the power supply is down in the shed.
So the small node, you can probably get past your HOA.
Oh, yeah. So,
What are you pointing that at? What you know who you're pointing that at?
yeah, let me get forward a couple slides and we'll talk about our network and the network in general. So talking about our uses, number one use that we've got, that is our Bardell. You said 19, when did we put Bardell up? Like 08? It's over 20, it's like 20 years ago.
No, it wasn't 20, it was
It's gotta be more like 15.
10 years ago.
15.
Yeah.
So anyway.
It was like 15.
Bardell is our remote control system, and you can see there at the bottom with the cameras turned off, DMR's on, the 5 gig, and we got 3 5 gigs on, the Pi's on, and we're able to send email. This is how we remotely control our repeaters and meet our FCC requirement for being able to turn them on and off. You notice on the bottom it says 2 meters now controlled by All-Star. The next screen down is the All-Star. We've got our 440 and our 2 meter repeater connected using the AREDN backbone to both of the repeaters, and we've got a remote base. And so that's how I was able to check in from South America, from Antarctica, came in here through All-Star, through the internet. And yeah, I'll agree it's cheating. It's not all RF, but boy, it sure is nice. Top is our remote HF capability. All of our club members can operate our HF station remotely. The HF station does have the hex beam on it. You can change the antennas between the loop and the hex. And so we have full operation there. And then our last operation is little cheat. I didn't have a picture of the screen grab. That's the camera on top of TCC Tower, and its purpose is to look out at the weather as it comes into Hurst and provide us visibility as to what's going on. We used to have 2 cameras. One was over in Richland Hills and the other one's here. Once we took down the Richland Hills Tower, this camera provides us our insight to what's going on. Questions about our applications? Oh,
It's not a question, it's a statement. I just want to point out to everybody that part of this is through the effort of John and Doug. They are using their homes, their internet, and so forth as part of our network. So my hat's off to them for the job that they do, basically hosting all of this for us. We wouldn't be able to do it without you guys, and we the club, and we very much appreciate all your efforts.
you're a great straight man, just one slide early. I appreciate
You
it.
didn't brief me.
I apologize. I didn't know. All right. So this is our, obviously, the US has got boatloads of signal, 5 gig, 3 gig, LOW, massive stuff. There are supernodes, there's 54 of them right now in the world. Supernodes are basically set up to isolate traffic between nodes. And they're basically connected via tunnels. Now our tunnels, by the way, are encrypted. So our point-to-point over the internet connections are encrypted. This is the worldwide picture. You can see that AREDN lives in a lot of places. And if you want, we can go on. You could go online. I don't have it set up, but you could go online and look at what is the 5 gig, what is the 9 gig, what is out there by frequency.
AREDN operates in small networks, but via the supernodes, you can actually connect to the worldwide AREDN backbone.
Yep.
And have your AREDN, or you be on your local AREDN net, and potentially talk to somebody across the world via the AREDN network.
And that's where it can be fun with IP. Because all you got to do, if you got an IP phone, you put in the other guy's IP address, basically his phone number, and you can have a voice conversation with AREDN. And I can't stress how valuable the VoIP side of this is, because when you pull people in from a CERT team or from an emergency management team, if you hand them a phone, they know how to work it. You hand them a radio and they freeze.
So with the VoIP phone, for instance, are you only able to talk to other people on AREDN, or like if you hand it to like a CERT member,
If
they can just call?
if you have a gateway, you could dial out.
Okay.
But by default, we just basically AREDN goes node to node. So yeah, if your VoIP switch has access to the outside world, yes, it'll work just like auto patch.
Okay.
So this is our AREDN system. We started the TCC tower where we've got the DMR repeater, the 2-meter repeater, and the weather camera. We've got 3 nodes over there. One points to the north tower, currently not connected to anything. One points off to Richland Hills to the southeast. And then one points due south down that blue line. As you drop down that blue line, the first thing you run into is Doug's house. Doug happens to be in a perfect place to talk to TCC. And he's been kind enough, and his wife is kind enough, we are going to say thank you, to connect us to the internet. So that provides us a gateway to the internet. And then we have a second gateway that talks through the Richland Hills. But anyway, moving down the blue line, we hit the Cheryl tank. We're going to talk more detail about Cheryl. Steve's going to take us through that in a minute. At the Cheryl tank, we actually have 2 AREDN dishes on a solar panel with a battery. And it is 24/7 battery operated, not connected to anything, and provides full functionality for us. That relay allows us to communicate with Fire Station 2 here, where we've got our 70 centimeter repeater, the DMR remote base, the HF remote control, and we've got the desire to put in a Brandmeister repeater, and we'll see if that happens. We've actually got some equipment to make that happen. We just got to get permission to use it. And all of the sites you see, we got access and control. We can remotely turn on and turn off the repeaters. We can put them in racing mode. We can put them in parrot mode. We can basically control everything remotely.
You can link them.
You're right. We can link them. And they're actually for the 440 net, we probably should look at linking them. Of course, the debate there is if we put the 440 and the 2-meter together, will anybody use the 440? And that's the whole purpose of that weekend, is to exercise 440. Moving off the blue line, the red lines here are actually tunnels. We tunnel out of the TCC site with the 5 gig card, and that goes off to my house with the node, which is connected to the internet. And we also do the same here out of the Hurst station using a cable provided by the city. Those 2 links with Doug's link provide us with a mesh. If I go out, Doug backs it up. If he goes out, I've got it covered. And so we are able to keep this network alive 24/7 by multiple paths. Questions, thoughts?
Authentication, like, so we're using, basically, we're overlapping with, 2.4, 5.8,
Yeah, yeah.
gig, which is, folks that got, so how do we prevent people that are not authorized access to this from accessing these networks?
Okay, Ardent, basically, we have our own protocol and largely on not normal, other than the 2 gig, we're outside the normal band. So our mesh technology is different than the commercial technology. So while they're both, 2 gigahertz Wi-Fi, they're different modulation schemes.
So if they had the same, I mean, I guess if someone were.
Yeah, if somebody cloned it, the way that most of them are set up, they would be able to just connect. If they have the right connection information, they could connect in.
That would just get them on the network. The
Right,
control of the repeaters or whatnot, and still have an additional layer of authentication or whatnot to be able to do anything with that.
Do they have, so they would have access potentially through the internet, through your internet if they had it? Like the concern I would have is like people that would abuse it. People that are not, I just like from a liability perspective.
we have the ability to lock things down a bit. We can log down node to node, like the endpoints don't allow Wi-Fi access. They don't allow WAN access. So if somebody connected into our network, they would not be able to get out because the only way you can get out is through one of the tunnels.
Okay. So as long as you've got appropriate controls.
Yes, and we actually surpassed the standard for Hurst IT for our passwords in the system. So even if they got on, yeah, potentially they could try to get out, but the way it's set up, they don't have the tunnel access.
Okay. Thank you.
Question?
So this network gets out to the rest of the world through you guys' internet, is that right?
Well, it allows our members access through All-Star and Echolink, or actually it allows any ham that comes into our node access. It isn't really access to the world.
Okay.
You can't easily hop on it and do all of your surfing for personal use across it.
Oh, right. But the way it gets out is through you guys' internet, right? So
Yes.
at the internet in this region, city, DFW, wide.
Yeah, and that is part of the reason that we've got different locations that are 3-4 miles apart. But yes, the key is if we lose signal, by the way, that blue line lines up nicely. Fire station 1 is a little bit to the north and it's got coverage from our system. The jail and police and city hall are right at the 121 interface, right above Doug's place. And then fire station 2, of course, is us. And there is fire station 3 down here. So if the city's internet went out, which it would do after 72 hours of power outage, we still can provide backup. And we actually have deployed a node over to the city hall and it does work. Now, granted, we're only talking, cities used to gigabit, would be down in the 10 megabit, but hey, in a pinch, it does work. And that's what it's about, is the emergency backup. By the way, as has been said, this is isolated. We are not connected to the AREDN global system. Something that we should be talking about, but at this point we haven't. We've taken somewhat the same view Mansfield's taken. We're a little bit, actually, we're more promiscuous. Mansfield only allows Mansfield members into their network. We're set up by the AREDN standard, so anybody that followed the standard could come in and connect to us. But that's our local system.
There's AREDN in Dallas.
Yes. Yeah, there's AREDN in Dallas. There's nodes up in Grapevine. Again, Mansfield with another one, Arlington. So we're not all interconnected. With the tunnels, we can't be. Actually, when Jason was with us, he actually joined in and he did tunnel through. And there's been one time that I've watched it where we actually connected because of a weather inversion our nodes connected to the nodes in California. And you wanna talk about some fun? That was fun. Just, you know, connecting to their nodes and seeing what they had, what their cameras were showing us. It was cute. Now, it only lasted for an hour and a half, but it was fun. All right, so Steve, I'm gonna turn it over to you.
One question, John. Peter, clarify, I think I was daydreaming when you explained exactly what you meant by tunnel. Is that RF?
No,
Physical?
it is a internet tunnel,
The VPN
a
tunnel.
VPN tunnel.
So that's just the wires connected.
Yeah, yeah, largely. It goes, on this end and my end, they're both wired. At the TCC site, we're using,
The cellular one.
cellular modem. So that's where we're using that, kilobit cellular modem to connect the server.
A VPN is a
Virtual private
a
network.
virtual wire though. I mean,
Yeah.
it's not an actual wire. It's an internet tunnel.
Yes.
You switch some light on back here.
Yeah.
See my people.
You need keys.
I have a question up front, John.
Question.
Yeah,
Speak up.
I just wanted to, when you were talking about that inversion and connecting with California, you're not talking about on those high frequencies that.
Yeah.
Really?
Absolutely, yes. We had
Wow.
we had a storm layer that came in and I have no clue. The signals were bouncing from the California hills up through the clouds into us.
Wow.
And it worked both frickin' ways. It was just propagation nirvana.
Interesting.
Now granted, like I said, 90 minutes, but well, it was exciting. Jeremy and I were playing with it and we were fairly new into this stuff. And it's like, oh my God, these guys are available.
Last thing you expected.
Oh, yeah, well, today we'd do it all with tunnel.
Yeah.
We're joined into the super mesh and we could connect.
Now, if there were enough node size between us and the closest super node, we could do this all.
Oh, through RF. Yeah, well,
But there's a lot of dead space between metropolitan areas across the
yeah,
country.
well, and as Steve goes through, when he's ready. Let me,
If you're just gonna stay back
I
here,
don't think so.
that should pick you up.
it'll pick you up.
That mic should pick you up.
Go ahead.
Got a question here.
Go ahead.
Go ahead, Jeff.
Hey, my name is Jeff, M5XHI. I have an old HSMM node been up for.
Breaking in and out.
Jeff, your audio just cut out.
Like he's muted again. Gotta unmute himself.
All right, Jeff, you've muted.
Hey, can you hear me?
Yes, you can.
Okay, I'm on the road traveling. We're going down here to Corpus Christi, but I have a HSSMM node up. I've had it for 20 years, and what I need, I'm disabled. I need somebody to help me to remove the flat panel antenna from the tower and put a new GLIN repeater in it or router in it, so I can use it for 2.4 gig. And I would like to put up a SXT 5AC dish up, and that way we can maybe get into your network. But since AREDN is looking at the 802.115AX routers, I'm just wondering if I should wait to have somebody put that up, because it would be a point to multi-point beam antenna.
All right, Jeff, I'll tell you what, send me, send Steve, send the club, where you're located at and how high up that antenna is. And we can do a path analysis and come back and let you know if you could connect to us. And if you can't connect to us, maybe you'll be able to connect to somebody else. I'm not sure where you live. But yeah, you've got the right idea. The equipment you got is is out of date and would not work anymore. The nodes you're talking about, are both good choices. Let's find out where you're at and see what we can do to connect it up. Steve?
Minimum for the city, I think it's up about 25 foot, so it's not very high. But I had intentions putting a weather camera up there to see Fort Worth, and I never did do it because the antenna now is a pre-70-80, and it's not worth trying to use. But yes, I'm interested. I'll get with Steve and see if we can set up something and get this thing going.
Works for us.
Alright. So, like John said, the hardware, the 5 gig, 2.4 gig are line of sight. And so before you invest in the equipment, you want to know whether you stand a chance of it working or not. And what I'm going to show you today is how we study the paths, determine if there's a problem or not, and try to resolve those. We'll show you one of the problems was with the TCC link to here, and why it was an issue. What I like to do is I like to start out with just Notepad and take notes of what numbers I use for a particular study. At the very top there, we get the numbers for the TCC. And so I haven't run this ahead of time, but we're going to do it today. Live demonstration, right? We're going to do the North Tower. And let's see, I have an address here of the North Tower. Copy and paste that. And we need to know what elevation that is. So I've got a website here, freemaptools.com. And you can plug in your location. I'm going to paste that in there. And it'll give me an estimate of the elevation and get us in the ballpark. And so it says that's 590 feet. And it also gives me the coordinates. And we cut paste all this. That's elevation of ground, right? Above sea level.
That's sea level.
Above sea level, yeah.
That's ASL.
MSL.
That's it.
All right, and we take those numbers and we'll plug those into another website called Radio Fresnel to generate a 3D Fresnel zone as a Google Earth KML file. And we can load that file into Google Earth and we can see what that signal path looks like. Like that. It's Berlin, Mass. Tower in Berlin. Okay, and let's see, let's start, I'll plug the ones from TCC Tower in. Right there. The name in. Coordinates. Sometimes I get these reversed. Elevations. But usually about, you can have 5 or 6 digits after the decimal point for the coordinates. And that'll be west and north. And it's easier to do it in feet. And that particular tower is at an elevation of 610 feet. And the tower itself is 180 feet. So for the study, we're going to use 790. So that's all the numbers we need for PCC. And let's come down here to the North Water Tower.
I hope everybody caught that. We've got the elevation above ground and then the elevation of the antenna above that. So add those two together for this tool. Other tools, all you have to do, it has places for both. It'll tell you how high it is off the ground, and then you have to add how tall is your mast.
Does this work for like long distances? Like I think on the first slide you talked about in Hawaii, they can go 200 miles. Obviously, you got the curvature of the earth.
Yeah, the tools take it into account.
Okay.
John,
And so,
you don't mean ground, you mean sea level?
See, yeah, well, yes, it's elevation above sea level, yes.
plus the height of the antenna, but ground. We'll change this to gigahertz, 5.895 gigahertz for one of the channels that we
So-
use, and we'll set this to zone 1, which is where if you have an obstruction, it's really going to affect you in zone 1, which says how big of envelope that the radio signal is. That's it. Once you plug these numbers in, you say get KML. There, distance too long. I think I've got my coordinates reverse column. Forgot to change this one to west. Usually that means you did something wrong, you don't get an error. Just thinking.
You know, you did it right when it takes a minute to compute.
So we can generate we've got multiple of these tools, but we generate coverage maps for our repeaters. We can generate coverage maps for the omnidirectional sites, you know, how far can we see? So what Steve's generating here is a point to point, which was gonna be using, well, we could use 3D, right? An omni and a directional or two directional. And the path that he's putting together is what we're using from here up to the TCC tower. Actually, you're generating a path to the North Tower?
Yes.
PCC to north.
I'm doing a live
A
demo.
brand new one.
Brand new one, yeah. Let's see. There it is down here. There's the, I'll be using Google Earth Pro, which is an app you can load on your PC. And for me, that works better and faster than trying to use a web-based one. There is a web-based one. I'm just gonna double click that file and it'll bring out Google Earth.
What was the name of that first website you had?
Free map tools.
Free map tools.
And I don't remember how I stumbled across this stuff.
And this is where it gets fun. Okay, with that.
Yeah, it sure is. Wrong place. Let's see. There's Walmart.
Higher because it's not that much of a distance.
What happened to the, yeah, what happened to it? It should be there.
Oh, there it is.
Oh, the yellow line, okay.
That's just we need yellow line with yellow roads.
Yeah.
Yeah, I did specify in yellow color. That choice, I guess. And elevation's off, man. You can see I'm way up in the air, right? At the North Tower. Just take a look at we can look at 590. So. Okay, there's my other mistake. I got meters instead of feet. That's the other common mistake I made. So I said, tell them, get the camera again.
When I did that on a transatlantic flight, ran out of gas.
And it still do that with fuel, pounds versus kilos. Only one day.
Yeah.
Or if you do it, make sure you're.
Well, no, NASA did it, they missed Mars.
The polar lander, I think. Polar something.
Yeah,
15 minutes out.
they missed the whole thing. One guy cost them all those billions of dollars.
It was a cheaper, faster, or better. You get two of those.
2 out of the 3.
Yeah.
Of the,
There we go.
So you double click on the screen and it will zoom in. Well, it's close. 26.
Yeah, it's sort of overshot it a little bit, it's going through it.
So I noticed in Google Earth, you can actually get the elevation too. I don't know how accurate it is, but like if you just mouse over that in the bottom right, I think it actually says the elevation.
Now,
Can you use a starting point knowing your altitude? And is there a tool that would apply like a compass effect where it would show you as the bar reaches
yeah,
from there?
I've dropped out the name of the site, yes. Typically the RF coverage, or like RF projector,
Yeah,
the VHF Society uses, that's exactly what it does.
okay,
They go in at the height, they put your antenna gain in, and they say, okay, this is how far it'll radiate out.
yeah,
And it will show you based upon, like, from here out to Colleyville, it will show you the dips where the handhelds won't pick it up.
oh, okay,
So yeah, you can, if you do a study, if you say, okay, I'm here and the antenna's there, it'll tell you like I'm 6 foot tall with my handheld and 5 watts. It'll tell you, not gonna work, or yeah, you should work.
so does it, account for, building interference and
Oh,
stuff
yeah,
like
yeah.
that? Like a percentage of success when you get
Yeah.
that far out?
And actually that's what we saw with the Sherrill Tower. We had put, we put this antenna up, we put up the antenna the other end, and it wouldn't connect. And it's like, okay, we're not high.
Hope we find something soon.
Yeah, but we didn't realize, and what Steve found with the mapping he's doing is that beam went right into the side of the Sherrill Water Tower.
Yeah.
And probably about 3 foot above the Sherrill Water Tower, there's a beam that goes across, and it shoots probably 40 foot above the top of our tower here. So that's why we put the antenna up over there, because an antenna sitting there catches the beam, and then it sends it out at a level that we can see it here. So it's not going over, it's going in too. And so that was eye opening. Now, one of the things that one of the main developers of AREDN had said is the AREDN signal will go through, it'll go through anything, it'll go through air, but it won't go through a leaf. If you get 2 or 3 trees, your signal will not make it. If you put 1 tree in a way, the signal will drop by more than half. It is amazing what leaves will do. So if you've got as we were talking about, I'm 20 foot up a tower. If you're above the tree height, this is a good thing. And the number one, when we first did this a decade ago, Chris had one of these up at his house, and Jeremy Hill and I sat down and got in the car with one of these, and we had to get within a half a block of his house to connect to him.
Because of the trees.
Because of the trees. Now, once Jeremy put up his 70-foot tower, we got a phenomenal signal between TCC, his site, and then from his site to here. Because there were no water towers, there was nothing. It turns out Steve's model, we do have some interference in the Fresnel zone from the buildings. But the signals get through.
It'll tolerate a certain amount of that.
Yeah.
But in the interest of time, I'm gonna jump to one of the files that I've tweaked and got everything right on.
Good idea.
We can work on the other one after the fact.
This is TCC to where?
This is TCC to here.
Okay.
So this was the one we couldn't even get a link to at all. You can see the repeater shack down below. All the antennas are on top of the tower. If you hold shift down as you move your mouse, you can tilt things and look at it from different angles. You can spin it around and look from the other way. You do need a fairly steady hand.
And that's why you're driving.
And I'm using the right arrow key, I'm going down the path, then you can see the signal above the ground there.
Whose house?
Boulders. Another mesh though, John.
Yeah, that's right. You got it. So, yeah, right there, City Hall, the conference center.
Yeah.
And that group of trees right there is Doug.
Just don't know if what's on the tower will shoot you too much.
Probably not. We can pick it up. I can get it from I can hit it just about below it, so.
If you wanna fly more quickly, you can zoom out a little bit like I just did.
I'm a block north of City Hall, so maybe it's too low. Not likely.
DCC towers, we're up on almost 200 feet there.
Yeah, I would suspect that the GI pole would potentially work.
Zoom in too fast. But you can sit there and you can tweak on like the altitude, your coordinates. 5 to 0 this one into right where the tower is. It doesn't render everything in fantastic detail. Like we can't see the tower, but we can see like all the different units up the top, the parapet wall, the two deals there. The hex beam is also right on top of this tower.
Depends on the last image from Google, last flyover.
Right.
So it could be 2 years ago, so. pretty good.
Yeah, you kind of gotta take like the foliage and stuff with
So
a grain of salt.
So you basically are looking at this and going, okay, I know this, I'm in the vicinity of a lot of trees.
right there,
Okay,
you can see it.
yeah.
That just took out half our signal.
Do y'all
So we're-
cut the tree now?
We're shooting through the tree, but right there.
But if you saw like, I mean,
Say about that.
Just show up.
And there, right there, there is the Cheryl tank.
There's the problem, Chuck, right there. When I saw that, I was like, there's no way we're gonna get a connection that way.
so if you had, I mean, you could look at this and go like, if you had permission, you could say, I could put up a 20-foot tower.
Yeah.
And go, I could probably just clear all of it if you had permission. You could use this tool to make that analysis.
Right.
Yeah, well, that's exactly how we got to where we're at. That was where we came up with, we need to put a relay on Cheryl.
Because like, we don't really have the option of putting a tower on top of this structure. Or putting something up here.
We're at about our limit.
Yeah.
The mount that was built in is failing, doesn't have any, there isn't any guidance.
Side row.
So if they went another 20 foot up, we would become unstable.
Okay.
And we become an eyesore and.
Yeah.
Historically, that's been a problem.
Yeah, I guess how much slot we need to factor in there.
So,
I don't know.
is he,
On that, I
Too
would
much.
try.
okay,
Yeah.
that little light area, that's where our relays sit.
Yeah.
That's right here.
It literally is right on the edge of that.
There's the ladder. Where our climber goes up.
He was here.
Like,
Clay,
He had to go.
yeah, Clay's been kind enough.
okay, so let me close this one. And this is the study we did with Doug Howe.
So much energy on.
Most important thing about this is the cheapest you can get involved. If you want to put up on our node, we said we give you the coordinates of where our antennas are and the height, and we can sit down and you tell us where you're at, like I said. Yeah, there, like the guy, tell us where you're at, we'll run a study. Or you can run the study. It's a whole lot cheaper than buying the equipment and discovering that you can't
Not
talk
gonna
to
stand
anything.
a chance. So up here on the left in the center screen, left center there, I'm gonna double click on Doug's plates. And it'll fly us to that location. And then you can double click on the location to have it zoom in. And Chrome gets a little iffy if you click more than twice. Gotta be careful, you get zoomed in too far, and you can click to make it stop zooming. But
That
here's
you're gonna have to pull over.
tip of Doug's house right there.
Seriously.
I do too, but you're not gonna be in storm.
I'm like,
You see how nicely that worked? We went between the trees.
And over his neighbor's house. Just dragging there. Let's roll out a little bit. I'm holding down shift.
Guarantee you that's an older scan.
More trees.
Not as, there are a little bit more trees. The shed is different.
The shack.
Shack.
The enclosure.
Yes, the radio enclosure, I like that.
But he misses the chimney, of the neighbor's house. So Don climbed up on the roof there and set the note on the top. Yep, got a connection.
Steve in the back of his mind is going,
Yeah, I told you.
and I told you that was gonna work.
Right.
Didn't I tell you that was a clear shot?
Yeah, that little outdoor node also runs 80.
And so we're really up in the air there. You gotta be concerned about freeways, that kind of stuff, you know, how high those get. As long as you don't block the signal too much, you're gonna have a strong signal and pretty reliable connection.
The city hall.
Gotta get through the damage.
You just hold on shift and move your mouse. Swing around. Sometimes you think you're hitting something on this and you're not. You know, you swing around like, oh yeah, we cleared it. You know. So that's about all I have. I'm gonna see if I can figure out what's wrong with that. Study to the north tower.
So. For about, I'm okay, so $160 in 2 nodes. This guy would get you connected to the internet. Critical, yeah, really critical piece. This node won't connect to the internet by itself. It uses a VLAN. And so to get this guy to connect to the internet, you've got to come through another node or a VLAN aware switch so that you can come out of this, connect on VLAN 1 and have VLAN 1 go off to the internet. The other thing I'll tell anybody, if you are going to be programming this guy, you need a dumb switch.
It really does.
It's really, really important to have a $20 dumb switch, just a 4-port base thing, because that will keep your computer connected to the node when the node has to power cycle. And without it, getting it to load can be a 3, 4, 5 time frustration. Not that it can't be done.
If we do the study and you want to do it, you don't want to mess with trying to get it programmed initially, one of us could
Oh,
do it for you
yeah.
easily.
Yeah, my laptop is loaded with all the goodies. He's got one loaded with all the goodies. I know Steve's got one, Travis. So there are 4 or 5 of us that have.
Getting the initial software on there is not the easiest thing in the world. Updating it after the fact
Is very easy, most of the time. So, other questions, thoughts, applications? I mean, it is actually amazing. There's actually just a Hamvention. There's a YouTube video from 2022 that talks about a lot of the new pieces. There's actually a new video out for somewhat parks on the air. This node with the battery pack and computer in a backpack. I'm gonna go out and do it myself in the AREDN in the park. And we actually have done that here. When we were up at Chisholm Park, we had an AREDN node that came back here. And when we've been back here, which is a no-brainer, we put up an AREDN node that connects in. So when we work from the parks, we can actually have internet access. And from the fire station, we've done it a couple times. So as we're showing, people, I don't think people pay attention. The internet's everywhere. So when you say, oh yeah, here, we got internet access, it's like, so what? The fact that it's going RF doesn't come into their head.
So that, again, touching back on that first thing you talked about, like the very long range, like the 200-mile, is that basically a good application of like the 900 megahertz? Was that how they did it? I mean, you could like
I think they were running on 3 gigahertz, but yeah, the 900 meg would be much more forgiving for obstacles than the 3 gig. The 3 gig though, of course, has higher bandwidth.
now, but that extreme range though, I mean, how do you get around the curvature issue? You're kind of like, unless you're, I mean, I'm trying to understand how you get that kind of range.
Well,
when you use these tools, it not only tells you the height and everything you're gonna have your antenna at, but it'll also tell you the elevation and the pitch you need to make your antennas.
But 200 miles, I mean, that's.
Yeah.
Yeah, well, okay, so you think about like the cliffs of Dover, over to the top of the mountain, the volcano on the other side. If you're, I don't have the right names for my Hawaiian mountaintops.
Yeah.
But you're basically going mountaintop to mountaintop.
Right, yeah, okay,
What are they going from Oahu to the Big Island?
The site over, the 200-mile site that I'm on is over in Europe.
Oh, okay.
And so I'm not sure.
Yeah, they could go from England, right? I like your concept.
I think it's south. I think it's more Italy, Crete kind of area. But it's, again, as long as you get up on top of that, you get on top of a mountain. Or, you think about Dubai, you get up on top of that, the top of the towers down there, you can talk a distance.
All right, guys, a little closer to North Tower.
A little better.
We're above ground and we're a little bit north there, you can see. I'm a little bit past the center of the tower. But it's pretty close. I took the coordinates off of Google Maps for this, and that gave me a closer location. Not sure why the other one didn't generate a decent number from the.
It's the old age old, right? Check twice and calculate once.
But I can sit there and tweak the altitude and put this down at ground level and know what the elevation is a lot closer there. I can move it a little bit farther south. Then we can guess at how tall that tower is, try to put something on top of it. To actually figure out how tall is that structure. Any
I think 150.
think it's that much?
yeah, Rebecca, you sent out that, what's that antenna?
Oh, yeah.
Cause it's got the antenna heights on it, right? What was that?
I think it does. I don't know.
But
if I
towers.
can find it.
All kinds of tools that you should look for. There are all kinds of tools you just gotta look for.
Yes.
Antennasearch.com. Yeah, so if you type that in, you'll see all the towers and the tower heights. And well, assuming there's an antenna on, I don't know if it would be just if it's a ham radio.
Probably not. Because, you're right. I have gone through that site. And it's got pretty much anything in the OCC databases in there.
The
AntennaSearch.com.
let's see. So is the idea like, well, basically this invitation, like if we can set up road nodes and then connect into this Hurst node, is there like some idea that we would like maybe exercise that, like, we do, for our repeaters, we use it, we get on weekly nets. I mean, are we?
Yeah, we're predominantly what we've been using this for is command and control, looking at weather. If we stepped up more with CERT, or if we were like Cowtown, like with the Cowtown Marathon, that would be a phenomenal place to deploy an AREDN node with a camera and be able to, provide crowd view of what's going on at critical points.
Yeah, maybe feed it back to the.
And that's exactly what we do, is feed it back.
So maybe we have like water stops, and if you got an AREDN node, set that up and send it back.
Exactly, that's exactly, that is the use that they're put, that is the bulk of this, because it is the emergency data network. And it's just amazing that you can sit down and send video.
And it is not internet dependent. We have internet connectivity. But you can do all of this node to node to node in an emergency situation.
And that is the design.
And that's primarily what it's designed.
That's the question I had earlier, is lost WAN. the mesh network is still online.
Still totally
Oh, yeah.
online.
Oh,
As
yeah,
long- As long
absolutely.
as you're on the mesh, you can interface with anything else on the mesh.
So, I understand like how we're using it now mostly for, video and command and control the repeater. We have, it sounds like we have this option to connect to this. Is there some idea like if club members connect to this, we would use it in a different way? That we would do more things than we're doing now?
Oh, yeah, chat, email, WinLink, I mean, all those are
Do you have a list-
applications.
Do
that
you have a
are-
list of the applications, the hosted applications?
I don't have one that I could pull up quickly.
Can you pull up a node interface? We should be able to see the list there. If you go into the node itself, we should be able to pull up that list of applications. But there are things like chat, there are things like WinLink interfacing.
Yeah, there's chat, email,
There's a VoIP phone service host, I think you
yeah,
can bring up.
yeah, time server, VoIP.
Time server, all kinds of different things that you can host on these nodes themselves.
Actually, I guess that would be maybe my one suggestion. If we were inviting like club members to connect to the node, that maybe we have some application that, they could interact with more than what we're doing now.
We could do a weekly chat check-in. Have a net, have a net that's done on the chat that's hosted on the mesh. We don't have the chat running yet, bring it up. And then have people at a certain time do exactly what you're talking about.
Yeah.
I'm gonna have to
do
defer to my
Discord and
counterpart
just
because my
meetings.
computer just decided to run out of battery.
Okay. Yeah, we got
Try not to shut up.
Yeah.
Yeah, there's an array, there's like 60 applications. And pretty much anything that we do with computers can connect through it, be used through AREDN. So, while we haven't had the need to set it up, we're using it as a utility. If we were to connect to the US AREDN mesh, then yeah, without a doubt, we'd be able to employ IP phone, we'd be able to do chat, we'd be able to do WinLink, email, all of those are functions that we could have.
And the way the mesh works, when you're logged into the mesh, you can hop to other members of the mesh. If we were on one of the super nodes that went out to, let's say, California, you could click your way through the mesh, end up on a California system and use their local chat. Yeah. Via your home system, if you're on this setup.
Yeah, and I know we can operate our node like separate, but is there? We mentioned before, like we talked about Dallas. I know Cowtown also has, Cowtown Club has their own AREDN. Now I don't think they're very active or we don't really talk about it a lot, but is there some idea that we would connect these nodes or is there really no advantage to them?
Well, right now we can connect them through tunnel. And
Because I mean, you could probably do by RF. I mean, they're close enough.
unfortunately, there's a big hill between us and Cowtown. We're in a hole, they're in a hole, so we gotta find a relay between us. Or if we could get on one of the tall buildings in downtown Fort Worth, they could shoot to it, we could shoot to it, and we'd have a signal.
Yeah, that might be possible.
And yeah,
Or we can find another.
What about the Cheryl
Yeah.
Tower? What about the Cheryl Tower?
Cheryl Tower's way too short. TCC.
Just on that hill where it's at, I can see skyline perfectly. In Fort Worth. So curious.
They're in a hole over there. We gotta get, it's not, like I said, if we can get to the sky, if we could get a node on the skyline on a building that could see, that Cowtown could see, we'd instantly have a signal. We'd have a solid signal.
Good idea for site survey.
But we gotta find the right people.
That's the problem, is finding who in the club is.
I will say this, and I can't say this enough, Hurst is just a blessing. The city of Hurst has, the water department, the fire department, even the PD. Everybody that we've worked with has been just really phenomenal. Things that this club does are not possible in other cities. So we are just blessed with the right people.
Climbing a water tower is not possible in a lot of places.
Yeah, right.
Just Jeff put out
Bring up the installable service list.
a note that says he's trying to set up a WinLink post office.
Okay,
just FYI. That's, it's in the chat.
well, if we get,
I'm trying to, I'm waiting for them to approve me, that's.
oh, is that what's holding it up?
That's what the
Okay.
holdup is, I'm waiting on the bureaucratic.
So John, I definitely see
Where's-
the application I see an opportunity for application to search usage and would like to further discuss those opportunities.
You're sitting right there, man. You got the ball.
No, as I understand here, how we might deploy it.
Yeah, well, and that is.
Paths to go with.
Yeah, it really, one of the big challenges I've got with all cities is the IT department thinks that their signals are solid.
There we go.
And Hurst actually, I've heard that Hurst is using dark fiber. So if they're connected through point to point on fiber, if they don't have a relay, they're gonna be solid because they got generators on both ends. They'll be good. It's folks like, like me who have a site, 6 blocks away that has a battery in it.
Yeah.
And when that damn thing goes dead, I'm out of business.
That's something on my end too, that I'll be looking at is backup power.
Has our presentation concluded?
Yes,